Hello, everyone. Thank you for joining me for this webinar. I want to talk today about a really important topic that I think is mostly ignored. And the reason I think this is mostly ignored is that I see what happens time after time after time when companies are hacked and data is leaked and things like that. As I was preparing for this webinar, I ran into a really interesting memo from the White House. No, it's not about Russia. This is actually from the beginning of this year. And this is called the Zero Trust Memo. And the primary thing that it says, and this is like a 30-page memo full of really interesting details, and I encourage you to read it because it expresses very succinctly a really important factor. Zero trust cybersecurity. Whenever you are, you have to assume that you're operating under a hostile environment. And that is true even in your own environment, even in your private network, on the internet, in your home. Everything, you always have to assume that you're operating in a hostile environment. Let's take a look at this. This is the trivial, typical scenario. Typically, we're saying, okay, we have everything outside the moat is nasty, hostile, nefarious, all sorts of things. Inside the moat, this is where we trust. This is where we know that everything is good. And that has been the typical approach. We're talking about DMZ, demilitarized zones. We're talking about firewall, proxy, reverse proxy. There is a whole world of VPNs. There's a whole world of network infrastructure that is meant to protect us from the outside world. And the whole idea is that inside our own environment, we can ignore security. The security is the problem of the moat, not us. I can punt all of my security decisions to the network engineers. The developer team doesn't need to know anything about that. And this is wrong. This is wrong because this sort of approach leads to this. A single break into your environment means that you're done, paused, everything is out. Now, a key factor here is that this does not apply to, people who work from the mother garage or unprofessional teams or something like that. I want to give you this exact scenario. $250 million support records. And the underlying issue, misconfigured security role in a database. Not normally accessible to the outside world. What actually happened here is that Microsoft had a Elasticsearch cluster, and it was set up on the internal secure network. And because it's running on the internal network, well, I don't need security for that until someone changed the firewall rules. And that someone had no idea that they're exposing this vulnerable service. But almost immediately, people jumped on that. Just to give you some idea how bad this is, there is a tool called Shodan. And I can go here and search for Open Elasticsearch data. And here is one with 10 gigabytes of data. I have no idea what we have in there, but apparently some news, probably logs. That might be interesting. And again, this is literally me searching public information. And doing things like that leads to losing your data, leads to basically the entire environment is just gone. And again, this is Microsoft, not someone who is known for being lackluster about security, certainly not since the 2003 era. Recently, there was also the SolarWinds incident. If you're not familiar with that, SolarWinds is a network management software. So this is what you use if you have 10,000 machines in your environment that you need to manage, apply patches, policies, so software, a whole bunch of other stuff. And this has been used in critical environments, military, defense, hospitals, many places. The problem was that someone hacked into SolarWinds, and they were able to put spyware, or basically a malicious version of the software as a software update, which means that the infrastructure management system was now under the control of an attacker, a malicious entity. And that thing had access to effectively everything. So a hospital network, a defense contractor network, a military network, and again, we are now talking about, I need to update my infrastructure system. So I'm taking the update that I have from the authorized location and applying it. And now I have accidentally introduced malicious software into my environment. And if I'm assuming that the network is secure, I don't have a defense in that. This is something that I really love. I talk about this quite often, the fallacies of distributed code. And in this case, we have the fourth fallacy, which is the network insecurity. And this is a fallacy because it takes one endpoint that was compromised to leak everything over the network. We have to assume at all times that we aren't, that someone is listening on the network, intercepting our calls, messing with the systems. By the way, here is something that we learned that is almost the reverse of security. We had experience trying to troubleshoot really strange errors with RavenDB. And the underlying reason was that the user was not using secure network. Because it was not using a secure network, it was communicate on the internal network, perfectly safe as far as the customer is concerned. It was using a plain HTTP, which meant that the antivirus on the client machine, on the server machine, the network appliance, everything along the chain did packet inspection and modification, other stuff that I don't even understand why they did that for. But it messed up the communication channel in ways that we couldn't predict, all in the sense of increasing security, but actually causes issues. If you're using encrypted communication, then nothing in the middle can modify what you're doing. So that eliminates a whole spate of problems, even without touching the actual security aspect of it. So why not always run in a secure mode? I mean, surely more security is better, but there are a couple of really good points, actually, about the cost of security. Security means that I have to do authentication, encryption, I have to spend CPU cycles doing that. I'm in my internal network, why do I care? Almost, even if you just ignore that, let's say we have the spare capacity, and we do have the spare capacity. The encryption algorithms that we use today are really fast. So that's generally not a concern. It used to be that you had to do a SSL acceleration, that you had a box that did just SSL because that was that costly. Now this is something that you don't really care. And the reason I say you don't really care, I have here, a Raspberry Pi. And on this machine, which has core 1.75 gigahertz, I can do hundreds of thousands of, tens of thousands of requests per second with no issue, with security. The other issue and the primary problem, the primary problem is about complexity. The issue is, how do I manage security? I have to know things. I have to make security decisions. I have to know everything. For example, what is an X509 certificate? What is their performance? There is this number that I have to know. This is, by the way, client authentication using the some crazy format. And I think that the most important aspect is this: the complexity and the management of security. Those are the true costs. But what do you lose if you don't get it? So here are some real discussions that we have with clients. Oh, I'm running in a Kubernetes environment and everything is under the private network and it's already encrypted by the underlying Kubernetes machinery, so I don't have to go up. Until the day that a single one of your pods has been compromised, at which point you now have access to everything inside Kubernetes. Oh, I can go and look at this database. Oh, there is no security whatsoever involving there. Let me pull off the database, ship it to my home base, and see what sort of value I can get on that on the black market. And especially if you're running in the cloud, it's very common to say, oh, I have a demote again. I have my virtual environment, I have only access through those particular locations, and that's safe. And as we saw in the case of Microsoft, 2 years from now, no one remembers that he made a security decision about blocking access to this. And the network admin decides that he needs to debug something, so he add a rule. Oh, I'm going to allow access to this subnet. And suddenly your environment is on the public internet. And there is one really interesting metrics about that. From the moment that a machine is accessible to the internet, if you boot a machine and measure how long it takes until someone tries to hack it, the average is 1 to 5 minutes. That's the time frame that you have everything on the public. If you have an IPv4 and you're accessible, someone will try to hack you, guaranteed. Shodan is one tool that does network scanning as a service. There are many others that can do that. So we have to assume that the network is hostile. So RavenDB has two modes. There is the no security. And in this case, RavenDB says, I'm only, by default, I will only allow you to run me if I'm accessible only for localhost. And this is suitable for testing, this is suitable for development. There is no other scenario where this is a viable option. On the other hand, then we have the secure mode. And there is a reason that this is a very binary operation. If you're running in an insecure mode, you cannot use encrypted databases. For example, just something very simple. Why? Because you're in insecure mode. There is no sense of saying, oh, I'm running an encrypted database, but the encryption over the wire doesn't exist. There is no notion of being able to restrict access to one database from a user if I'm not running a secure mode. So RavenDB make it hard to run in an insecure mode. You have to explicitly choose that multiple times. The whole idea is that by default, you fall into the secure model. And we spent a lot of time around making sure that as you run in RavenDB, you don't really need to worry about security. We are taking all of the honors, all of the burden of running a secure mode in the appropriate third-party review recommended manner. And for that reason, RavenDB assumes that it's running in a hostile environment. Technically speaking, if you're running RavenDB inside your local environment, your Kubernetes cluster, your private network, you don't need security. And some cases, we see people, oh, how do I do SSL termination in RavenDB? I want to terminate the SSL connection at the Kubernetes cluster level, and then inside the cluster, I want everything to be unencrypted. And the answer is that you don't do that. We don't support that scenario. Either you run in a secure mode or not. There is no half and half. Doesn't make sense for the reason already mentioned. And I actually found this, and this was absolutely beautiful to see that. This is from the World War II, and this is pretty much the same now. So let's see how we boil it down to practical behavior. RavenDB is going to do everything possible to run in secure mode, which means that by default, you start RavenDB, we give you the setup result, and there is the choose, bring your own certificate, get the let's encrypt one, or run in secure, and we are really trying to push it away from it. If you're doing the setup manually, then you have to explicitly choose again and again. I want to run in a secure mode. RavenDB will actually refuse to run. If you're trying to set up RavenDB, oh, I want to listen to all network ports without security, all network devices. So if I'm on the public internet, I'm going to listen to the public IP address. RavenDB will absolutely refuse to run. It will return an error. It's a nice error, tell you, hey, here is what you have to do if you really want to run it this way, but it makes you stop and think. If you run in a secure model, what does it mean? It means that all communication is encrypted, so encryption in transit, and you have the option of encryption of the data to the distance. Now, when we start talking about security, we realize that, dear God, there's a whole world. of things that you have to do properly and nicely and no much fun stuff like that. Crazy complex. For example, you may, I'm using SSL. Well, that is a generic term. If you're actually using SSL, you're worse off than being actually unencrypted. SSL has been hacked for, I don't know, 15 years. The current term is TLS, and there are versions to that. And modern security practice said that you should be using TLS 1.2 or 1.3. So RavenDB enforces that. We actually accept connections using older protocols. So you can connect to RavenDB using TLS 1.0, which is an insecure model to do. But the reason we do that is so we can give you an error. Hey, this is not secure. This is why this is not secure. This is how we fix it. And this is part of a whole design decision that if we aren't going to make the secure model approachable and easy to use, it's not going to be used. That's why instead of rejecting flat outright the old protocols, which is what you would typically do, we say, oh, I'm only accepting TLS 1.2 or 1.3. And when you try to connect, you get, oh, connection closed, which gives you no indication what's going on. It's a mystery debug. You get a proper error back. For that matter, let's talk about, so we talked about encryption, but let's talk about authentication. In this case, we have to talk about two authentications. From the client to the server. So when a client connects to the server needs to know what permission does this client have. And we do that using something called X59 client certificate authentication. What this basically boils down to is that the client and the server are exchanging the public keys, signing them. There is a whole world around that scenario. I actually have several blog post series on exactly how it works, and I think that is fascinating. But you don't need to know any of that. It might be good extracurricular knowledge, but the whole thing that you need to know is that industry best practice. So we actually, when we designed the security system for RavenDB, we looked into all of the regulation and requirements that existed in the market, and we chose the one that was most that was most accepted across the board. So this is the highest level that you can get. And the idea here is that the client certificate uses cryptographic primitives to authenticate. There is no password involved. There is no something to remember. And on the other side, so we talk about the server trusting the client. This is done through cloud authentication. On the other side, if the client connects to a remote server, how do I know that this is the right server and not someone else that I don't trust? Because that's also a valid security concern. If I can put myself in the middle, I can lie to the client, I can get important data from the end user, etc. So the client is also authenticating the server using the standard PKI trust, public key infrastructure. I will touch on this later. So let's talk a little bit about what this is. There is something called an X59 certificate. And this is more or less what it is. This is some envelope format that contains public key metadata and the relevant duration for this particular certificate. This is signed by some authority. Now, so far it doesn't really mean anything, but the idea here is that, and there is something called root authorities, root certificate authorities. Those are the people that I trust to verify certificate that they issue. So for example, probably the biggest root certificate authority right now is Let's Encrypt. So my machine is trusting the Let's Encrypt authority to issue certificates and validate that they are the right certificate for the domain that they're using. Again, whole world out there that you can dig into and really interesting, but the important thing about this is that this is the basis for all online security in the world. This is how you ensure that hackers aren't pretending to be your bank. This is how you ensure that when you're buying something at Amazon, no one can get your credit card information. This is how pretty much any modern system is secure at this point in time. So inside of RavenDB, I mentioned already TLS 1.2. TLS, by the way, is another way to say HTTPS. HTTP plus TLS equal HTTPS. We are always mutually authenticated, as I mentioned, and that has some really interesting implications. First of all, the entity that does the SSL termination is the RavenDB server itself. You cannot have a man in the middle. Now, you can have routing, absolutely, but that has to be blind routing. Take the raw bit stream from the client, pass it to the right location. That's it. This is because we ensure that there can be no man in the middle, that the client and the server trust each other. There is no firewall in the middle that might want to interfere with this and things like that. And that means that no one on the network can eavesdrop. The nice thing about this, even if you have an environment where you're transparently replacing the signed certificate. So let's say I'm running on an internal network and the domain administrator has installed a local CA so they can monitor traffic. And there is some appliance that is issuing the request and decrypting them and encrypting back with the certificate that I trust. RavenDB will refuse to run in this model. Why? Because the client is going to try to authenticate to the network appliance, but then the network appliance will not be able to authenticate against the RavenDB instance. So we ensure that there is nothing in the middle. Now, you might want to say, oh, I'm actually want that, and I'm going to install the client certificate at the appliance level as well, which is obviously going to work. But this is now a very explicit step and not something that just happens. It also means that the host must match. And this is a really important consideration. You typically see RavenDB using as a.ind.ravendb.cloud. And if you try to access that using localhost or using the IP, it will not work. Again, you have to, because we're using HTTPS and we have to match those things. This actually has a really interesting side effect. Because we do the security at the connection level, we only have to do the security check once. And then all future requests are naturally bounded to that security operation. Conversely, if we did that on a per request basis with API token or something like that, we'd have to do the security check on each and every operation. That can be incredibly expensive. So now we get into some really interesting details. The idea goes like this. I have the XML certificate for authentication. once I authenticate, I trust you to have that set of permissions that you have. Notice that this also has an interesting implication. I don't try to revalidate the certificate on the fly. Once a connection is happened, I'm going to calculate a set of permissions for that certificate and keep that for that connection as long as it is running. For example, if I'm connecting to a node and I have access to database A, if I later add access to that certificate to database B, then if I'm using the old connection, I will not be able to do that. If I create a new connection, then I will be able to do that. It's in general never an issue, but something to keep in mind. From the client to the server, I mentioned that we have the hostname, certificate match, the usual things that we do in order to make sure that HTTPS works. If you ever had to deal with certificate GPS management, stuff like that, that's the normal thing. From the server to the client, so how does the server trust the client is a more interesting thing. So one thing that would work is if I register a certificate on the server. If I told the server this certificate XYZ is trusted to access at this level. This certificate can access a database A, this certificate can trust database B. So far, so good. And it works and it's wonderful. But there's a problem. How does the server in a multi-server cluster, how does the server trust each other? I mean, I could go and register the certificate for each one of those, but this is a really annoying problem. I have to register each server in each other of the servers, and that's inconvenient. So RavenDB uses the idea that it will always trust its own certificate. And a very common deployment model is that all of the nodes in a cluster are using the same certificate. What is the impact of that? I'm deploying the nodes of the cluster, and then I'm trying to connect from one node in the cluster to the other. And they authenticate using their own certificate. So in this case, the certificate is both for server authentication and cloud authentication. And if the server that accepts the connection notices that the client authentication for this connection is the same as its own server certificate, it trusts it. Now, there is a caveat here. The server certificate is always trusted. This is the case even if it expired. Why is that? Consider the case that I have a cluster with, and that's actually a really important aspect, certificate expired. And if I'm trying to connect to a node using an expired certificate, it's going to reject it. But that does not apply if I'm using the server certificate. Let's say that I'm running a 3-node cluster, and it's using a certificate that is valid from January to March. And I didn't replace the certificate. Well, now it's first of record. No one trusts that certificate anymore. And I, as the administrator, want to update that certificate manually through the studio or some manner like that. So I go to one of the servers. I ignore this is an expired certificate and try to upload the new certificate. Then I fail because the node that I'm working with cannot authenticate other servers because they're already expired. For that reason, there is an exception that says if the server that I'm connecting to is using my client certificate as its server certificate and vice versa, there is trust regardless of the expiration. when we generate a client certificate, we sign it using the parent certificate, the server certificate. But the typical duration of a server certificate is 3 months. This is what, for example, Let's Encrypt allow me to do. I don't want to replace the client certificate each time. So I typically issue that for a period of 1 to 5 years. Again, this all depends on your own security, behavior, and policies. But that means that RavenDB, when it validates the certificate, it doesn't take into account the validity duration of the parent certificate, only of the actual client certificate. And that actually leads us to a really interesting issue. How do I maintain trust in a cluster when the certificate may be updated? So consider this case. I have a certificate for my application. I got it from John. It's valid for 6 months. I registered that as an access certificate to database A. Now I'm running. What's going to happen when I'm going to, after 6 months? That certificate is going to expire. It's no longer valid. However, RavenDB implements something called public key hash pinning. And the idea goes like this. I got this client certificate from John. If John issues me a new certificate using the same public key as before, between a validity period, I'm going to automatically trust it. So the rule here is that I'm going to trust an unknown certificate if and only if it matches the public key of a registered certificate and it was signed by the same authority that signed the original certificate. If both of them are true, then I'm good and I'm going to trust that certificate because this is a renewal of existing one for the same authority. This turns out to be really important when we're talking about cross-cluster systems. Let's imagine that I have a cluster in London and a cluster in New York. And I want them to trust one another, to do a external replication, ETL, a bunch of other stuff. Each cluster has its own certificate. And I'm going to register each cluster on the other side with appropriate permissions. But those clusters are being managed by different teams, by different companies. I'm not going to have to ask you, oh, every 3 months, go and do this trust registration, because this would absolutely break at some point. That is why public key hash pinning is so important. When we renew the certificate, we renew it with the same key from the same authority. So we're able to renew the trust between the two clusters automatically. And that's actually a really important aspect. I'm running 2 clusters managed by 2 separate teams, companies, etc. I establish trust once, and then even though they update their own certificates, the system keeps on working and is robust and stable. Now, what happens if I'm running on a partial trust? We have this notion of inter-replication, and that allows me to pull or push data to a remote location that I do not trust. A great example is if I have a laptop that may fall into a competitor hands. So I can register this endpoint, this certificate is allowed to touch, to read and write those prefixes. And you can say, you can read these prefixes and write to these prefixes, etc. Prefix, I mean the start suite of the document ID. So only some of those documents will be replicated. And again, all of the usual behavior of trusted through certificate, mutual authentication, but in this case, we assume that the other side is nefarious. So we do active filtering on both ends. The client doesn't trust the server doesn't trust the client, to make sure that we're not touching anything that we should. I actually have a webinar just on this topic. So I think that was quite interesting. Now, let's talk about some deployment models. By default, I'm going to assume that you have no idea what certificates are. That's, something security, someone else problem. So you can use the automatic setup. This is called the Let's Encrypt setup inside of RavenDB. Based on your license, you will get the subdomain in one of those. And then RavenDB will handle everything for you. Would handle the subdomain, generation, registration of the certificate, validation of the with Let's Encrypt, the whole thing. You can actually go to customer.revenue.net and manage your certificate, DNS separation, stuff like that directly in here. On the other hand, if you're running an environment which says, oh, I want to run everything in-house, you can do that. You can have a certificate on your own hostname using your own systems. By the way, you can actually use Certbot, which is one of the common tools for Let's Encrypt, to do everything automatically. But again, the entire infrastructure in this case is owned by you and managed by you. So some things about the environment and how it works. If you're using the Let's Encrypt option, RavenDB will manage everything for you, including updating certificate, distributing trust, all of those sort of things. If you're not doing that, then you need to have some mechanism to update the certificate. One way of doing that is, oh, let's generate the client certificate, the server certificate for a year. And we set up a calendar reminder to do that. And if you do that, I will guarantee we have done that. At some point, you will forget. And if you do that in this manner, then it means that, oh, I forgot that we have to go and buy a new client certificate, a new SSL certificate, etc., etc. So you almost always, and actually always, want to automate that. So however you do that, it may be that you're using your own CA, you have some process, whatever. But the basic idea is that whenever RavenDB is well suited to automatically handle those updates. So we will read the file from the disk every 50 minutes, every hour, and if it changed from what we have in memory, we will distribute that file to all of the other nodes in the cluster. What this means is that you can just say, oh, I have Certbot, and Certbot is going to output, I'm going to register that through a cron and run it every day, and it will automatically regenerate the file based on my own environment, the certificate file. RavenDB will read that, process that, and move on. I push that to all of the cluster. I don't really have to think about that. You can also do that manually through the studio. This is mostly meant as a admin, one-time, emergency, those sort of things. This is not standard operating procedure. You can also integrate that to Kubernetes secrets. Again, the whole idea is that you push the Kubernetes has its own certificates, and you can expose that as a file system to RavenDB, and then the usual behavior of, oh, it's got updated, I'm reading, pushing that, etc. In some cases, you may also want to run using vaults, HashiCorp, Azure vaults, those sort of things, using a hardware security model, those sort of things. RavenDB allows you to register commands that will be invoked when it wants to read a certificate or to update a certificate, and that allows you to integrate with those things and to generate this properly and without, having to support each of the thousands of options that I have. Okay, so this has been me trying in 45 minutes to give you the gestalt of security for RavenDB. As a reminder, the assumption is always that we're running a hosted world, always running a hosted network, and we always have to have encryption authentication optional. To the maximum extent possible, we are trying to ensure that you don't have to think about security. Security is supposed to be something that I'm concerned about, not you. And the end result is that RavenDB is always running in a secure configuration. Just some other aspects. We asked Jason Donnerfield to do a review of, Jason Donnerfield is the person behind a VPN for Linux, not Wireshark. I'm drawing a blank here. There is a VPN that is now inside of the Linux kernel, and it's one or something. I don't remember. And he verified our assumptions and our behavior. We are doing annual security review and penetration testing of RavenDB, and with great results. We actually had one of the most common complaints is, why are you still trusting TLS 1.0 and 1.1? We're not trusting them. Your tool doesn't recognize that it is able to connect just to get an error. And without, if you have any questions, now is the time. Wildcard, that's the term, wildcard. Okay, we have a question. No, we don't have a question. We have a reminder. And this is the RavenDB Cloud. I haven't touched about the security aspect of RavenDB Cloud, mostly because they are the same or better than what you have inside of RavenDB in general. We utilize the same infrastructure behaviors. A reminder, if you haven't started using RavenDB, you can get a free instance in a couple of minutes. And we offer you to do a live demo with RavenDB. So you can register, and we have one of our developer advocates talk to you and help you with any questions that you have about RavenDB. And with that, assuming there are no further questions, I would like to thank you. I know that I've tried to push quite a lot of details in a succinct manner possible. I hope that I was understood. If you have any questions, feel free to send us an email. Thank you very much, and goodbye.